It sounds like something out of National Treasure. Thomas Jefferson, mysterious maps, and a dangerous secret buried beneath a famed national park. The first hint to this secret showed up in 1805. A map, sketched on a bison pelt, showed the Yellowstone River, and next to it, a picture of a volcano. President Thomas Jefferson hung this map in the entry hall of Monticello, his estate. Then, famed explorer William Clark of Lewis and Clark jotted down Native American accounts of a sound like thunder that makes the earth tremble, coming from Yellowstone. The indigenous people already knew something about the secret. In 1870, an expedition arrived at Yellowstone to chart the area. They named the famous geyser Old Faithful, and while there, a soldier guarding the expedition looked out from a high peak and remarked, "The park sure looks like a big old volcano crater." It took almost another 100 years to fully confirm that casual observation and find the secret. It required plane travel, a government aerial photography project, and a lot of scientific measurements. There is a volcano at Yellowstone, one so indescribably vast that the eye cannot comprehend it from the ground. This volcano's caldera, the past fire-spewing maw, stretches over 40 miles, and the magma chamber below sprawls even beyond the boundaries of the park's 2 million acres. Past massive eruptions have blanketed the continent in ash. Apocalyptic. And none of this is the scariest sounding part. It's erupted in a cycle, about every 600,000 years. And the last time, roughly 600,000 years ago. So naturally, a question's arisen. This is Are We Doomed? A production of Nuanced Tales distributed by the NPR Network. I'm Ben Bradford. We live on a shifting, dangerous rock. Under our feet, under a thin, habitable surface where we grow trees and food and more humans, is fire and pressure, which occasionally erupts like a popped zit, and even less frequently erupts like a shotgun through the Earth's crust to devastating effect. That is often dubbed a supervolcano.
Supervolcano!
And no supervolcano has gotten more attention, or been the subject of more doomsday theories, than the one at Yellowstone. The facts I laid out a moment ago are true. It's apocalyptic in size. It has devastated life on the continent, and a recurring cycle would seem to make us doomed. How scared should we be? When I first started reporting this episode, I genuinely did not know the answer. Supervolcanoes are real, absolutely wild Earth phenomena. They can be globally destructive. I'm just going to cut to the chase, though. When it comes to Yellowstone, we're fine. At least for the foreseeable future, we're good. But what's most interesting, I think, is the story of why we're fine, how we know, and why the fear about Yellowstone's supervolcano still persists. And finally, all that focus may be obscuring a bigger risk. Maybe not a world-ending one, but enough to be deeply inconvenient to all of us humans. Let's first establish what a supervolcano is. And the best way to do that is to talk about what a supervolcano is bigger than. Which brings us to the largest volcanic eruption in the history of human civilization. 1815, an island in Indonesia, a mountain called Tambora, stirs.
Earthquakes and rumblings for maybe several weeks telling us that magma is moving up through the volcano.
Shanaka Silva is a volcanologist at Oregon State University who studies our biggest eruptions. He told me the story of Tambora, not a supervolcano.
It gets more intense with time, and then it pops.
It pops.
Yeah. Completely destroying the area close to the volcano. So most of the island of Sumbawa would have been covered in a thick blanket of ash.
anyone in the area around Tambora's explosion was dead. But its ash shot further, a marathon distance straight into the sky.
That then produces a kind of a haze in the atmosphere. This ash and gas and so on gets up into the stratosphere and acts as a filter.
The haze spread around the globe.
Actually impacts the Earth's climate.
It's called volcanic winter. This is what truly powerful volcanoes can do. Crops failed. In Ireland, there was famine. In France, food riots. In Massachusetts, they referred to it as the year of 1800 and froze to death. It's also known as the year without summer, all from a volcano in Indonesia. And the effects didn't stop there.
The summer was so bad in Europe that Mary Shelley and her husband and Lord Byron,
poets, authors,
they were so depressed that they wrote these very sort of dark stories. One of them was Frankenstein, and Lord Byron wrote the poem Darkness.
Including the famous line, "The bright sun was extinguished." Underappreciated consequence of volcanoes. Poetry.
Yes, science meets art, I guess.
It is not an exaggeration to say every single person on Earth felt the effects of Tambora's eruption. And every time you see a green stitched-up monster with bolts in its neck, you're still arguably glimpsing the effects. But remember, Tambora, not a supervolcano. Tambora is just our comparison point. The eruption that brought you Frankenstein is just there to keep in mind, as volcanologist Shanaka Silva tells another story of another hotspot, also in Indonesia, also for confusion's sake, starting with the letter T.
Let's zoom in now to Sumatra. There is a very famous tourist location called Lake Toba.
70,000 years ago, there was no lake. Toba was a flap of earth, overlaying seething, angry, molten rock and gases bubbling. This was a supervolcano, gathering strength.
The signs of this eruption may have started tens of years to hundreds of years before the actual major eruption.
Smoking, shaking.
Small eruptions, the wildlife would have been scattering.
Birds flying away, animals screeching at the sky, being like, what is happening?
The nascent human population would have been completely confused as to what was going on.
Shanaka says probably Toba began to swell.
You used the term zit earlier. So imagine a massive zit growing in the crust. And that zit produces a welt on the surface as it's growing. So that's the magma accumulating in the crust. Eventually, the top of that zit fails.
Implodes. It's like Gallagher smashing a watermelon. Except the watermelon is the size of Rhode Island and filled with hellfire. Volcanologists use a scale to measure the power of any given eruption, like the Richter scale for earthquakes.
In volcanoes, we have what's called a volcano explosivity index.
A name that is to the point. On that scale, let's graph 3 volcanoes to get a sense of their relative sizes. First, one we haven't talked about, but very famous.
If we take an eruption that probably people are very familiar with, which is Mount St. Helens in 1980.
Yeah.
That seemed like a really big eruption.
Mount St. Helens was the most disastrous eruption in U.S. history.
And that's a VEI 5.
Pretty big, but nothing compared to our next volcano, Tambora, of Frankenstein fame.
Tambora is thought to be 100 times bigger. So
100 times bigger than Mount St. Helens.
100 times, yeah. So Tambora is a VEI 7.
And finally, 70,000 years ago, the Rhode Island-sized watermelon, Toba.
Toba is almost 100 times bigger than Tambora.
Toba was 100 Tamboras going off, 10,000 Mount St. Helens erupting at once. That is a supervolcano. Toba is a supervolcano. It was a big one at that. Its eruption could have nearly filled Lake Michigan, turning it into the world's most unpleasant jacuzzi. Imagine the poems it would have inspired if written language had existed. Next, consider, if its little puny cousin Tambora caused volcanic winter, what would the atmospheric effects of Toba have been during its eruption 70,000 years ago? One school of thought is massive ice age. Toba may have changed the world's atmosphere for long enough and made it cold enough that it nearly brought humans in our cave-dwelling prehistoric infancy to the brink of extinction. It dwindled us to just a few thousand in number, almost cutting us off before we really got started. Now, that theory has come under question in recent years, but on a real maximal scale, that's what we're dealing with here when we talk about
Supervolcano!
These are real things. They are incredible. They are apocalyptic. And they can happen.
They're extremely rare, but they do occur in the geologic record.
Like I said earlier, we're fine, I promise. For now. But first, let me just scare you a little bit. Because if you follow the volcanic breadcrumbs, you could easily think we've got ourselves a problem.
Can I ask how many supervolcanoes we think that there are?
Yes. So the most likely location for a future super eruption is where there's been one in the past. There's 9 places on Earth that we've identified.
Okay.
3 of them in Japan. There's a couple in the Americas. There's Indonesia. And then there are some which get very close. For instance, there's the very famous the volcano in Italy, Campi Flegrei, around the Bay of Naples.
Now, imagine what it would be like if one of these 9 hotspots blew, went off like our big watermelon, Toba. Except in Italy, or Japan, or here. What would that do to us today?
I mean, we just have so many more humans and so much more infrastructure built up. And I understand that location would be a part of it, but
Location would be key, but, we saw what happened with a very small eruption in Iceland and the impact that happened,
15 years ago.
can you pronounce the name of that volcano?
I think it's Eyjafjallajökull. I hope I got that
That's
right.
very, very impressive.
Okay, to back up, Sean is saying that when this volcano in Iceland, blew, it caused global headaches, even though it had a VEI of 4, meaning it was a 10th of Mount St. Helens, a 1,000th the size of Tambora, and a hearth fire compared to our supervolcano, Toba. And yet, nevertheless, this volcano kicked enough ash into the sky to close most of Europe to air travel for days. It cost billions of dollars, and a lot of reporters had to learn how to pronounce the volcano's name. Even a few inches of volcanic ash can devastate. It kills crops, collapses roofs. If it gets wet, it's like cement. It gums up machines, short-circuits electronics, all of which indicates if a supervolcano did its supervolcano thing, we would expect continent-wide destruction, years of cold, famine from crop die-offs, just real bad. We would not be fine. And what if it wasn't just one?
There is now work going on that's suggesting that there may be paired super eruptions on sort of opposite sides of the globe.
We might have to worry about double supervolcano.
So, for instance, there's the Toba eruption. And then, as far as we can tell, there is a synchronous eruption on the other side of the globe in Guatemala.
Supervolcano twinsies. Or how about supervolcano symphony?
There are, throughout Earth history, pulses of these super eruptions. So you can imagine the impact of, well, what happens if you have, 2 Tobas going off instead of just one? Then you can start imagining that the impacts of these things will really multiply. And then you have a catastrophic situation for the Earth.
Why is the Earth doing this to us?
The simplest answer is the Earth, it had a violent birth.
Hurt people, hurt people.
Was born as basically a hot molten mass, and it's been cooling down since its formation, and that cooling down process hasn't finished yet.
So the Earth's troubled childhood results in these occasional fits of boiling anger. Of all the supervolcanoes on Earth, one has gotten more attention, has been the subject of more speculation and public worry that it might go off than any other. It is in our own backyard. I'm talking, of course, about the supervolcano underneath Yellowstone National Park. If we want to be scared, it's easy to do for a reason I've already mentioned, but that's more concerning to hear from an actual volcanologist.
Yellowstone has had 3 major eruptions, and they have an approximate period of about 600,000 years, the last one being 600,000 years ago.
But remember, it's probably okay. In a moment, Yellowstone hysteria, why we're not doomed, and why this all still matters. Regarding the massive supervolcano under Yellowstone, we are probably fine. Why oh why would anyone ever be under a different impression?
Yellowstone is due for an eruption.
It would look like hell on earth.
I wonder if there's ever been a breathless documentary or 3 on the subject.
That whole area is a ticking bomb.
Has anyone made a TV movie that could contribute to the hype?
Based on the latest predictions of leading scientists.
Look, there's going to be an eruption, okay? We know that.
Supervolcano, Sunday at 8.
Oh. For 2 decades, the Yellowstone supervolcano has played a recurring role in a certain type of cable TV documentary. And if you search the internet today, you'll get hits like eruption scenario, how it could change the world, which parts of the US will be devastated. And yet, I keep telling you, we are almost certainly fine. Why is that? And if that's right, why the disconnect? Why has hype of an impending doom spread so widely? There is one person who I think has the most direct and current window to help answer all of this, both about the volcano and the seething rumors around it. So I called him.
My name is Michael Poland. I'm a geophysicist with the U.S. Geological Survey, and I'm the scientist in charge of the Yellowstone Volcano Observatory.
Michael Poland is literally the scientist in charge, that is his title, of monitoring what's happening under Yellowstone. Michael's part bearded, rugged mountain man backpacking through tough terrain, and part absolute nerd about rocks.
My specialty is how the ground moves.
I asked him about the supervolcano. I asked him about the rumors. I asked him if we're doomed. But first, I just thought we should establish what is actually going on beneath Yellowstone. That bison skin map of Thomas Jefferson's was right. There is a volcano.
Underneath the national park, kind of in the central part of the park, is a solidifying magma chamber. It is huge.
You could say it's the size of a dozen Grand Canyons, although I think he hates that.
Sort of silly because it doesn't quite work that way. Most of the magma is solid, but it's still hot. And that's what fed recent eruptions, recent being sort of geologically recent.
The last supervolcanic eruption, it is a supervolcano, was 600,000 years ago. You almost certainly weren't born, and there have been smaller eruptions since.
But the last eruption was 70,000 years ago.
Michael says it wasn't big or violent, just literally the last time any lava came up.
Created a lovely plateau that you can go hike across today.
Because in between super erupting, supervolcanoes often spend their time as Volcano Clark Kent, trying to act normal.
They mostly have smaller eruptions.
Nevertheless, an almost incomprehensibly vast chamber lies underneath most of the park. But Michael says do not think of it as a bucket of liquid or empty space.
That's not true at all. Magma chambers are really complex mixtures of solid particles, of liquid melt, and even some gas moving around in there, sort of like a soda that's carbonated.
The soda occasionally fizzes up until the can bursts. 600,000 years ago, and before that, etc., it burst pretty darn hard. Some estimates have the force of a Yellowstone supereruption equaling the entire global nuclear arsenal going off 600 times over. What would that look like? Basically,
hell on earth.
Supervolcano, Sunday at 8.
Even Michael, who is as adverse to supervolcano hype as anybody, can't help but gush over Yellowstone's rap sheet.
So it would have been apocalyptic. I think it's a good way of putting it. Epically big, hard to imagine big. Here's the picture of what's happened in the past. In the big catastrophic explosive eruptions, they're putting huge volumes of ash and gas into the atmosphere. Blankets of ash roll across the ground. right in the area of the eruption itself, you sort of wipe the area clean with these ash flows that rush across the landscape.
What do you mean wipe the area clean?
Well, they are kind of hurricanes of hot ash and gas. They are rushing across the landscape. They are incredibly hot. They are incredibly fast. So they really just kind of wipe out everything in the area of the eruption itself.
Yeah.
Outside that immediate area, Yellowstone's eruptions dropped deadly ash over most of the continental United States. One eruption 12 million years ago, you were definitely not born, turned a portion of Nebraska into animal Vesuvius. It buried whole rhinos and camels and saber-toothed deer, helpfully preserving them for modern paleontologists to look at. And by the way, my editor asked me if this is true or I'm joking. This is true. It's called Ash Fall State Park. So, if a similar eruption happened today, if Yellowstone did blow again, it would be bad. Like, movie bad.
Supervolcano.
Even a few centimeters, a few inches of ash can be pretty destructive. It can cause houses to collapse, roofs to collapse.
It would do all the supervolcano things we discussed.
Supervolcano.
Might devastate infrastructure, agriculture, electrical, water systems, things like that.
It could cause global volcanic winter.
That might last years. And so worldwide, even if you weren't touched by ash directly, you would feel the effects of this.
And once more, it has happened in the past, 600,000 years ago, and etc. So why have I kept pounding the table that we are fine?
So the very basic question is, are we due for another super eruption? Are you basically observing a giant bomb that's going to blow up the United States right now, Michael? Is that your job?
No. If you want to use the bomb analogy, it's a bomb that's not primed.
I think he hates the bomb analogy.
It's not really ready to go. And prior to any sort of big event there, we would start to see changes. Volcanoes give warnings before they erupt, right? To get a lot of magma close to the surface and then up to the surface to erupt, you've got to accumulate it. That creates a lot of stress, pressure that causes the ground to deform. You get lots of earthquakes. And we just aren't seeing that right now.
We are fine because supervolcanoes do not strike with the speed of a comic book hero.
How long do you think that sort of loading period, if you will, would take?
It's really difficult to say. Melting rock is not an instantaneous process. Just because you add some heat doesn't mean suddenly the entire magma chamber turns molten. There is some speculation that it's at least decades. It's much more likely that it's centuries to millennia to really prime this system and get it going for an eruption.
With big eruptions come big signs. So if Yellowstone were about to blow in the cataclysmic way it has in the past, we would know. And the evidence is we would have a lot of time to plan, generations even. Instead, though, if anything, signs point away from another eruption. Michael says Yellowstone may actually be hanging it up, finally outgrowing its biggest tantrums.
It's possible that Yellowstone really won't do that much anymore. The plate is moving over the Yellowstone hotspot, and it's bringing an area of very thick crust over the top of the hotspot. And we don't know whether or not the hotspot will really have the oomph to burn its way through that thicker crust. So it's possible we may go into an extended period with not a whole lot of activity. We're talking several million years from now, really.
So Yellowstone is not going to explode in a continent-ending volcanic eruption. Certainly not now. Maybe not for millions of years, at which point you'll probably be dead, and possibly not ever again. So we are fine. And how we know we're fine seems like really simple. But none of this has stopped the hysteria.
We've got no food, and we've got no power.
The breathless documentaries.
That whole area is a ticking bomb.
Where did this come from? Michael traces it back to the early 2000s.
There was a documentary that was called Supervolcano, and that brought that term sort of back to the forefront. It really wasn't around much prior to then. And it coincided with a docudrama movie.
Supervolcano.
The movie and the documentary came out as scientists reported a plateau at Yellowstone getting taller, starting to bulge. A theory emerged that this meant magma was surging, which meant the bomb was priming. It wasn't.
The ground at Yellowstone is always rising and falling. And that's the same thing we see all over the place, really. That volcanoes everywhere like to move up and down.
But now, hype and rumors had settled in, And from there, it became a game of whack-a-mole. To this day, Michael, this scientist exploring this huge, wondrous national park, spends a lot of his time batting down internet conspiracy theories.
It seems like every now and then there'll be some random rumor that pops up that just takes hold.
Like a recent one. A flurry of YouTube videos suggested all the animals in the park were checking out. The subtext? Because a super eruption was coming.
Bison, elk, wolves. They're leaving the park in numbers no one's ever seen.
And the videos were all phony. I mean, the one video, so here are all the bears leaving the park, and it was filmed at a bear zoo in South Dakota, and someone just claimed it was Yellowstone, and millions of people believed that, and, now think there's something going on.
Michael understandably hates this.
It's a needless distraction from reality, really.
You could argue that the main danger of Yellowstone is not the volcano underneath it, but how it's long been another kind of hotspot for the kind of panic and hysteria and wild rumors that spread so easily across the internet today. So Yellowstone offers a cautionary tale for all of us to watch our information diets, to be wary of stuff that sounds like this.
There's gonna be an eruption, okay? We know that.
Now, this is not a doomed by disinformation episode. We will have that at some point. But I just needed to note it here. It's a key part of the Yellowstone supervolcano story. Sticky hype and swirling rumors that say we're doomed. And we're not. Not by this. We're fine. It really bothers Michael, the hysteria. And not just because he has to debunk clearly fake videos.
Look, Yellowstone is incredible. It's an iconic American landscape. It's the first national park in the world. It has boiling water shooting out of the ground. It's shocking, right? Half the geysers in the world are in that little corner of northwestern Wyoming. Just because it's not going to erupt and kill us all anytime soon doesn't make it any less spectacular.
Well, speaking of things that annoy you, how do you feel about the term supervolcano?
Pushing my buttons right now. Huh? Not a fan. And I will say that my opinion is mine.
I know Michael hates this word.
I think, first of all, it's kind of trite. I think it's a bit misleading because it implies that these things only have massive explosive eruptions, and that's not true at all. And I think it's misapplied. There are a lot of volcanoes that have never had super eruptions, which is probably the defining characteristic of a supervolcano, right? But they get this name, supervolcano.
To recap, our volcanologist, Michael, does not like the word supervolcano. He does not like bomb analogies. He does not like Grand Canyon analogies. You might think the scientist in charge of the Yellowstone Volcano Observatory is just a big grump about volcano threats. And you would be wrong. One reason Michael is so frustrated by the hype around supervolcanoes, and Yellowstone especially, is that it is not going to go off. And it's drawing attention away from volcano threats that actually might.
Other volcanoes that are much more hazardous, that are showing more signs of unrest, are more likely to erupt.
When we come back, the real volcano threats, where our angry Earth fires rocks, bleeding fissures of lava, and water at us.
Sort of like a pressure cooker gone horribly wrong.
And as usual, we're going to solve it. Briefly, based on what we've learned, let's do the doom meter. The risk of a supervolcano under Yellowstone spewing up from the ground, turning the United States into charcoal and hurling the rest of the world into volcanic winter. We are fine.
So it sounds like we don't need to be particularly worried about Yellowstone erupting and wiping us off the map at the moment.
Yeah, I'm not worried about a volcanic eruption in Yellowstone.
Now, that doesn't mean Michael Poland, scientist in charge, sleeps blissfully on a pillow of angel feathers each night. Hosting a supervolcano under your national park, even if it's not going to erupt, comes with some complications. Like earthquakes.
So there was a magnitude 7.3 in 1959 just west of the park. The largest recorded earthquake in the Intermountain West. It caused a landslide that killed over 24 people. It blocked a river, created a new lake.
Hot springs exploding.
Sort of like a pressure cooker gone horribly wrong.
Steam and hot water build underground until, boom.
There is A hydrothermal explosion crater in Yellowstone is 1.5 miles across. That's massive. If that were to happen in summertime, in the next few years, they would be absolutely devastating.
So there are dangers. Earthquakes, geysers, bison charge a few people each year who get too close, which is probably not the supervolcano's fault. These are not dooms, though. The bison can't get all of us. Not yet. But we've heard there are at least 9 supervolcano sites already identified around the world. Maybe one of these could go off, and then we could have...
Supervolcano!
I asked Michael.
I mean, we know that we have these massive world-changing eruptions that happen throughout Earth's history. So if Yellowstone is not a threat, do we have a sense of whether other places are dangers to have super eruptions?
Well, there's probably a couple of dozen volcanoes on Earth that have this capability. But those sorts of things are pretty rare in the geologic record. One every 100,000 years or 50,000 years or so. They just don't happen that often.
He says, like Yellowstone, none of those sites are showing the signs of imminent eruption, the precursors, the bombs being primed, the earthquakes, the rumbling, etc., which suggests, once again, that we're fine for decades, centuries, maybe millennia. So congratulations to you, because you are not doomed by supervolcano. We did it. The problem, Michael thinks, is that all this focus on supervolcanoes, maybe because of that attention-grabbing word he hates, super, has made it a struggle to get public focus on real volcanic threats. There are real volcanic threats that could change your and my and his lives.
What I'm worried about are not quite so super eruptions, but still really, really big.
He's talking about volcanoes akin to Tambora of Frankenstein fame.
And they're much, much, much more likely. Maybe you're getting one every 1,000 years or so.
Remember, Tambora caused crop die-offs, a worldwide winter, a year of 1800 and froze to death, and poetry.
Yeah, these eruptions are big enough to put a huge amount of material into the atmosphere. It would have an impact on global climate. It would have a devastating impact on the immediate area.
Now, add that to our complex, interconnected society today. The airspace closures that even a small volcano like Eyjafjallajökull, got it, caused in Iceland. We don't need a supervolcano to cause us headaches.
Those sorts of things I think are underappreciated by folks that don't really study volcanoes. They focus on the really, really extreme.
And because a Tambora is smaller, it's also sneakier. It takes less time to prime its bomb, less rumbling and earthquakes, less advanced notice. There are more possible locations it could go off. This is the urgent risk we face from volcanoes, Michael says. Not a world-ending risk, but deeply inconvenient. And so, Michael thinks, instead of panicking about supervolcanoes, we need to be aggressive against the possible Tamboras. We need to gather a posse and hunt them down.
Volcanoes give warnings. But in order to receive those warnings, you got to be listening.
Volcanoes need monitoring equipment.
And that can be done by satellite. Not everything, but satellites can do a lot of it. But you also need on-the-ground instrumentation like seismometers. And that way you'll detect when a volcano may be waking up.
How are we doing on that? How are we on monitoring around the world?
We're doing okay. I mean, it's gotten a lot better in the last few decades, thanks in large part to satellites and to decreases in the costs of a lot of equipment. But there's still maybe half the volcanoes on Earth that have been active in the last, several thousand years don't have any ground-based monitoring or don't have sufficient ground-based monitoring.
Yeah.
So, yeah, we're definitely getting better.
But it's not perfect.
We definitely need more monitoring on volcanoes worldwide in order to be able to say we've got all of these bases covered.
So we do the monitoring, we get that first part solved, and then what do you think is the next step there to mitigate them? What do you think the options are? Are there options?
Well, the best way to mitigate loss from a volcanic eruption is to not be there when it happens. In this sense, it's very similar to hurricanes. Right? We don't try to stop a hurricane from hitting a coastline. You tell people to get out of the way. Right? You evacuate an area. And that's what we do for volcanoes as well. We can't stop eruptions.
So we mitigate loss by evacuating. And to know where to evacuate, we need good monitoring. That is the reasonable and probably best current solution. it still leaves damage and disruption behind from Earth's tantrums. So what if we want to go further? Not just mitigate loss, but just skip the whole eruption. You're in luck, because this is Are We Doomed? Solves Volcanoes. Think about it. We have to worry about these Tambora-sized blasts causing... And eventually, if humanity manages to survive long enough, we will ultimately, maybe thousands of years from now, need to contend with another supervolcano and all that entails. So let's get ambitious. Occasionally, someone suggests a technological solution to diffuse volcanoes before they go off. Idea 1. We tunnel down into the earth next to a volcano, make a right turn, and then drill into the side of its magma chamber. Put a giant hose into the hole and pump cold water in to cool it down for thousands of years. This idea comes from no less than NASA's Jet Propulsion Laboratory. What do we think? What does our volcanologist Michael think?
I mean, it's like trying to use an eyedropper of cold water to cool a pot of boiling water on the stove. It's not really going to work all that well.
All right. Idea 2. We drill into the volcano itself, lancing the zit before it can burst. You might even be able to capture the heat for energy purposes. Clean energy, broken volcano, all in one step, perfect, right? I asked our other volcanologist who we heard from earlier, Shanaka Silva. He says,
if you have an overheating radiator in a car, the last thing you want to do is drill into that radiator, because this is not a good thing to do.
That would be bad.
Yes.
All right, fine. I got a whole bunch of other volcano fixes. We heap huge amounts of more earth over their calderas, smother them like a campfire. We design an enormous catcher's mitt that can contain a blast. Or we provoke smaller eruptions, so we never get the big one. A New Zealand mechanical engineering professor proposed these among 64 ways we might take down even a supervolcano. How about that? Huh?
All of them give me concern, I guess. Let's take provoking a smaller eruption. What you never know is, does a smaller eruption destabilize the system and then drive it to a much larger eruption?
Okay, maybe we don't have a way to stop a volcano, much less a supervolcano, yet. The scientists I spoke to say the power involved just dwarfs anything we can build. And that's okay, because for now, we're safe. I wouldn't rule out our great gazillion great-grandchildren coming up with a better solution, though. Supervolcano antidote. The whole history of this incredible phenomena, how we found them, how we figured out what they've done, and how we learned to predict them, is really a story of curiosity turning into knowledge, from the first indigenous map of Yellowstone to the scientists today listening for the planet's tantrums. That's pretty rapid progress. And if we keep it up and don't destroy ourselves some other way first, think about how much more capable we might be by the time the next supervolcano does begin priming its bomb.